Good afternoon, everybody, and welcome to the May edition of the Sustainable Futures Seminar Series. We've got two speakers today. We've got Stephanie Sodero, who's a lecturer in climate change and health at the University of Manchester, who's going to be presenting Under the Weather, Reimagining Mobility in the Climate Crisis. And we've also got Aristeidis Voliotis, apologies for the pronunciation, is a research scientist at the National Centre for Atmospheric Science at the University of Manchester, with understanding air pollution through aerial, ground-based and laboratory observations. So we've got two talks. They're going to be followed by, get around 10 minutes of Q&A for each talk, after each talk. So if you have any questions, do put them in the chat, and we can present them to the speakers at the end. Yeah, so thank you for coming. And I think without any further ado, I'm going to hand over to Stephanie. Thank you, Stephanie.
Wonderful, thank you. I'll just load my slides here. Beginning. Yeah, can you see my slides? All right, on that side, yes, thank you, Aristeidis. Hi, everyone. My name is Stephanie Sodero. I'm a lecturer in climate change and health at the Humanitarian and Conflict Response Institute at the University of Manchester. And I wrote a book, and I'm excited to tell you about it today. So here we go. Let's see, how do I change slides? There we go. So my research is based on my doctoral research looking at increasingly severe hurricane activity in the North Atlantic, impacting Atlantic Canada. So today I'm going to tell you some of the impacts of these storms, community, societal responses, and key concepts that I've developed in response to my research. So without further ado, here we go. So this is where we are. Home for me is Halifax, Nova Scotia, Canada, also known as Mi'kma'ki. And it was hit by Hurricane Juan in 2003. And Newfoundland and Labrador, also known as Katakmakuk, it was hit by Hurricane Igor in 2010. Both have been subsequently been hit by further and even stronger hurricanes. For my research, I conducted interviews with policymakers. I analyzed policy documents. I looked at media responses before, during, and after these events, and very interestingly, looked at legislative transcripts. How were these events talked about? Before I proceed further, I will acknowledge that my research took place on unceded Indigenous territory of Mi'kma'ki and Katakmakuk. I love this photo because there are two fellows who have made this canoe birch bark canoe using ancient technology. And on the front of it, they have their GoPro camera. So they are capturing the old and the new in terms of mobilities. Interestingly, makers of these birch bark canoes have noted that the traditional signals, the seasonal signals, like starting harvesting the birch bark in June when the fireflies come out, those are changing, and the texture of the birch bark itself is changing due to a warming climate. So, impacts of hurricanes in the North Atlantic. So this is the impact of Hurricane Juan on Nova Scotia, Mi'kma'ki. This was a storm defined by wind and storm surge. This part of the world is used to storms. This is nothing new, but the severity of the storms is something new. And this storm was so severe that you can see that it actually sunk a fishing vessel, giving you an indication of the severity. That being said, this was only ranked a Category 2 hurricane on a scale that goes up to Category 5. There were a variety of impacts on mobilities, on the movement of people and goods. For some smaller people, this was a source of amusement and fun, transforming the landscape. But for most others, after the initial novelty, it was an inconvenience at one end and moving up to dangerous at the other end. This is a scene from a residential street, and if you can imagine trying to get an ambulance to someone on the street or evacuate someone, it would be extremely difficult. Hurricane Igor was defined by flooding. So it was only a Category 1 hurricane, but the categories are measured by wind speed. So it was a very relatively slow moving hurricane. But what this meant is that it inundated the region with a massive amount of precipitation. So they received something like 20% of annual precipitation within a 24-hour period. And average stream flow increased from about 10 cubic meters per second to 600 cubic meters per second, resulting in widespread road and bridge washouts, isolating more than 100 communities. Newfoundland and Nova Scotia have very peninsular geographies, so often there's just one road connecting communities, and if that goes, you are disconnected. In my book, I include poetry to try and broaden the way we think about climate change. And this poet, she writes, "We realized then that we lived on a peninsula and the rocking for water surrounding us was actually the ocean slurping." So the idea of transforming social ecological relationships. So instead of the human acting upon the environment, it's actually the environment impacting the humans, and recognizing this and embracing it rather than resisting it. So that's part one. That's a brief overview of the impacts to give you a sense of the scale of these hurricanes. So next, responses. How was mobility adapted before, during, and after these events? So these are just a handful of examples. So one thing is, so this is a petrol pump. Petrol pumps rely on electricity. If the electrical grid goes down, you cannot pump petrol. So for in both of these storms, the electrical grid for sure went down, and most pumps did not work. Where the pumps did work, there was a run on them, i.e. there was a long line, a queue of cars and trucks and ambulances lined up to get petrol. And so they had to ration, and then those supplies themselves were run down. So this was one impact. Another impact, so there were these disruptions. In Nova Scotia, it was power poles and trees blocking roads. In Newfoundland, it was these extensive road and bridge washouts. So that dominant way of getting around using the road network was suddenly not a viable option. And it was really interesting to see all these alternative or shadow mobilities that emerged. So people used off-road vehicles or quads. You can see one here in the foreground. They used skiffs, ferries were seconded to different locations, helicopters, people ran through the woods, all kinds of different ways of getting around were used. The vast majority were fossil fueled, contributing further to climate change, but it was really interesting to see in the face of disruption that communities had different ways of getting around. They had the skills, the equipment, the knowledge of the land, and the will to help their communities. And one more response was very commonly in response to these events, we've never seen anything like this before in our lives. And in the very next breath, let's get back to normal as soon as possible. And so this is a very common narrative when you hear about disasters in the news, and it's very understandable that when the status quo is disrupted, that you kind of want to get back to comfort. But that normal, in fact, contributed to the severity of the severe weather event through fossil fuel use. So a question of how, in the face of disruption and storms, do we come back differently? In a more sustainable way. And one final response was that, very interestingly, in Nova Scotia, the hurricane was seen as one of many disasters that have happened, including weather-related disasters, but beyond. And so it was seen as a part of an ongoing narrative that we need to change the way that we're doing things. By contrast, in Newfoundland, it was very much seen as an isolated incident. Get this done, get the road network back up and running, and get back to normal, and not think about bigger picture issues. And this is a photo for historians in the group of the Halifax explosion, which was the largest human-made explosion before World War II, pardon me, and was invoked by research participants in terms of this level of damage caused by the hurricane. We have not seen this level of damage since the Halifax explosion, especially the impact on the trees. 1 million trees fell in the region. So having done all of that, I used my research as a springboard to think about different concepts. How can we reimagine social ecological relationships faced with a future where we have to reduce our carbon emissions, getting to net zero, at the same time as we're dealing with an increase in severe weather events and related disruption? So there are two concepts I will introduce here. One is what I call an ecological approach to mobilities. And in short, this is an evolution across different types of thinking about transport. So the first version is transport planning. This is circa 1950s to 1970s, but it still carries on. The idea that car is king, and it's about as many cars on the road, accommodating demand, getting from A to B as fast as possible. This has been supplanted in recent decades by the concept of sustainable transportation. How can we use different modes of transportation to reduce emissions and increase quality of life? And then to this, I add the idea of an ecological approach to mobilities. So beyond thinking about just human mobilities, how do humans get from A to B, we're thinking about how does floodwater need to move, how do animals need to move. It's a broader conceptualization that rebalances the social ecological. And just some examples, and this is from a table in my book, and it's my favorite table in my book, and comparing these different approaches. So for example, transport planning is about speeding up traffic. Sustainable transport is a bit about slowing down. And an ecological approach is about accommodating fast and slow movements of people and more than human elements. And so that's one concept. And the second concept is climate routing. And this came out of a concept called weather routing. I spoke with a mariner in Newfoundland. His job is shipping. And he spoke about the experience of navigating a ship in the North Atlantic. And he said, well, weather route to allow us to maintain the maximum speed with the minimum amount of energy. So this is all about profit and time and speed. So kind of aligning with conventional transport planning. But the way he spoke about it, the attunement, the continual attunement between the ship and currents, tides, wind, and more, so that the ship is constantly adjusting and attuning its course. And I thought, my goodness, wouldn't that be a neat, I thought of this yesterday, like the shipping forecast. So in the UK and being attuned to the weather. But what if we brought that attunement to the climate? And here on the right are trajectories, long-term trajectories for emissions reduction. So if we thought of the shipping forecast, but if we thought of that in terms of a climate forecast, what would that look like in contemporary society? So here are a few ideas that are by no means exhaustive. One is simply, easily, sure, revolutionizing mobility. And what I mean by this is, in my research, it became apparent that fossil fueled mobility was built into every aspect of life. You want to go to the doctor, you want to access school, you want to get to your part-time precarious employment, and fossil fueled mobility was integral to that for most people most of the time. So how can we do that differently? Second, prioritizing what I call vital mobilities. So this is an image from Newfoundland, and an NGO rep, she said, we need to get supplies from here to there. They have done this before. They had pre-positioned bottled water and cots with the expectation that people's homes would be flooded, but they had not experienced this level of region-wide infrastructure disruption before. And so there were questions about how do we get things like insulin, antidepressants, heart medication into people? How do we get people out to chemotherapy, to dialysis, and other appointments? So how, looking forward, can we prioritize what, these vital health-related mobilities? A third point is embracing green and blue. So this is essentially how in our everyday life can we create a greater attunement between people and the broader environment. And this is just one example. This is a smart fin that can be attached to a surfboard or a boat, a kayak, so that when you go for your wonderful summer kayak one day, you can enjoy the environment, but at the same time, you're collecting data about ocean temperature, ocean carbon dioxide levels, and more. So a little citizen science on the side, so that you are deepening your relationship with the environment that you're enjoying, and then perhaps are maybe an even stronger advocate for it in future. Another idea is rebranding redundancy. So essentially, what's the backup plan? If the road washes out, if there's flooding, whether it's in Canada or the UK or wherever, what's the backup plan to get this person from A to B, or to get this good from B to A? And one approach, this you can see here, someone guessed the other day that these might be Viking settlements, but these are actually what we call root cellars. And so they were used by settlers in Canada to store food so that it was kept warm in the winter and cold in the summer. So this was what refrigerators looked like pre-refrigerator. And so the idea that every community had a store of food. This particular community has about 100 root cellars. But what would this concept of root cellars look like if applied to decentralizing the power grid, to provision of healthcare? Yeah, how can we rebrand redundancy, have the backups available in communities so they are not utterly reliant on mobilities? And second last point is thinking flexibly. So, and this came out in the example of Newfoundland, if the main way of doing things isn't available, what are the options? So thinking about what are the alternative approaches and being flexible, for example, looking forward, expecting turbulence rather than laminar flow to be part of the everyday. So how can I adjust a schedule change, adapt to a schedule change or something like that? And finally, an ethic of care. And this is a video clip. I won't show it to you, but this is a scene from Nova Scotia that was of a storm that hit while I was actually attending the international climate change negotiations in Glasgow. And it was yet another severe weather event with a storm, a particular bridge washout in this community. And the community members rigged up across this fast-moving water a line, attached a pulley system with a milk crate, and used that milk crate and the pulley system to move goods back and forth across this river where there used to be a bridge. And I think there is something very humble about that, but also shows a lot of potential, and also the modesty of human efforts in the face of changing climate. And with that, I thank you for your attention. That is all. Thank you.
Thank you, Stephanie. That was really interesting. I personally was glad to see that sensor fin, because I've seen a similar approach used in Cornwall to measure water quality in estuaries.
Oh, fantastic.
So they use canoes as well, and it was really interesting to see. A reminder to, if there are any questions, put them in the chat. But I'll kick things off with the Q&A. with how can you include more marginalized perspectives in your research?
Yeah, so I focused on policymakers in my research, and policymakers at this time was largely middle-aged white men. The NGO representatives tended to be younger women, and I didn't realize as I was doing it, but well, I realized it as I was conducting the research. I wish I had done a bit more of course correction during that. But essentially, a diversity of views were not represented at the level of decision making. I'm hoping this will have changed since I conducted this research, but I had made, because of my advocacy background, I had made a decision to focus on policymakers, but if to do it again, I will focus on how the average Joe or Jane navigated these experiences in order to get a more diverse experience, a sense of the diversity of experiences. Yeah, thanks.
And a second question, how can you decolonize your research?
This is also something I'm thinking about a lot. Along with the book, the research and the writing of the book has grown along with my understanding of the links between colonialism and climate change, and my understanding is much greater than it was when I started this project, but it still has like so far to go. So, for example, including Indigenous perspectives and Indigenous mobilities, Indigenous approaches to dealing with severe weather events. I think there could be a lot to learn there. As well, in Nova Scotia, there are two main groups, the Acadians, who are French Canadians, and African Canadian populations who have both experienced profound displacements, the Acadians in the 1700s and Africville in the 1970s. But those communities experience those profound displacements and have recovered to some extent and kept their culture central. So I think there's a lot to be learned there.
I think that occurs in a lot of climate research in terms of when we think about the areas affected by climate change. Is that important?
It's been a steep learning curve, and it's kind of shocking that it wasn't more apparent earlier. But
what key actions would you flag to a political leader in your part of Canada?
I think we have to start having conversations about this stuff now, before the next big hurricane. The idea that we need to build some kind of community consensus or a sense of community direction, like where do we want to go as a community? What are important mobilities for us? If this road washes out, are we going to rebuild it to the same standard, or are we going to do something different, a different standard, a different location, invest in a different type of infrastructure? So yeah.
A question here, will your book be available at the libraries in Manchester?
It's a currently, great question, thank you. It is available, at the University of Manchester's library, and I'm not sure about other libraries, but it is available through the University of Manchester.
Hopefully it'll be available in the Central Library at least, and then maybe some.
Yeah, that would be wonderful. I would just love to go into a place and be able to like, I have to do that at the library here at the University of Manchester, just go in and take my own book off the shelf. That's going to be like life highlight. Right.
And where will you take this research in the future?
So I was really struck by that one quote from the NGO rep who said simply we needed to get stuff from here to there. But that was really hard to do. And so I've looked at, I'm focusing on vital mobilities. So how do we get societal circulations of goods and services that are required for internal bodily circulations and health and well-being? What do those look like? I've looked at donated blood, saline IV solution, medical oxygen, and these are often surprisingly geographically diffuse, right? Earth supply chains, so that if For example, Puerto Rico is a major producer of pharmaceutical supplies. And it was hit by Category 5 Hurricane Maria in 2017, and that means production goes down with knock-on impacts around the world in terms of groups that rely on those pharmaceuticals. So I'm gonna look at that a bit more.
It's I think the sort of idea of resilience in face of climate change is just such an important issue and growing. And it's not just an international issue. When you think about harm caused to the railway network, it's not designed for this climate in the UK. I mean, it's landslips, it's coastal erosion, it's flooding. These things are all increasing in number. So
yeah, definitely. And I've given some extreme examples from Canada, but these same issues are so applicable to the UK in terms of flooding, heat events in the summer. Heat has an impact. It can cause rail tracks to expand and trains have to slow. It changes pavement. So yeah, this is unfortunately all too relevant to the UK.
Yeah. Well, thanks again.
Thank you. Thanks, everyone.
I think we can pass over to, I'd have to apologise in advance for get your name wrong again, Aristeidis, for your time.
No, it's okay. I had a crazy moment of panic because during the talk, my computer shut down and started updating itself. So I got panicked. I was running around trying to find
timing for it. Your Windows.
Finally, I'm in on time. Give me a second. I'll share my slide.
That happened to me, Aristeidis. I gave a talk about a month ago, and at the very beginning, the computer shut down in a way it's never shut down before. So
yeah, exactly. This is what happened to me. So let me share my screen. Can you see my screen here?
Yep, look good.
Excellent. So, hi everyone. I'm Aristeidis Voliotis. I'm an early career research scientist at the National Centre for Atmospheric Science. I'm hosted by the University of Manchester in order to manage the Manchester Aerosol Chamber. Now, in this seminar, I'm going to show you how aerial, ground-based laboratory observations shape our understanding about air pollution, and I will showcase some of the research basically that we're doing here at the university. I will start with the first mention of air pollution that I could find by Hippocrates in 400 BC in Greece, who said that all sorts of illnesses are being related to the quality of air. A bit later, Lucius in Imperial Rome noticed that his health were mending after he left the city. So all of this is telling us even 2,000 years ago, people were understanding that air pollution affects their health. I'm sure you're all familiar with this. I had a lot more slides about the development of history and air pollution, but I have to cut them short. I'm sure you're all familiar with this. This is the Great London Smog. So where extreme cold weather and favorable meteorological conditions led to an unprecedentedly air pollution episode that yielded 4,000 deaths or up to 12,000 according to more recent estimations, hundreds of thousands of illnesses, and led basically to the first Clean Air Act a few years later, where local authorities now have the power to control the emission and set up smoke-free zones. Since then, air pollution became a global issue. So the United Nations conference in Stockholm in 1972 recognized acid rain as an important international issue. A bit later, the transboundary air pollution was recognized again as an issue that requires international cooperation and highlighted the need for more monitoring and research. About a decade later, the IPCC, so the Governmental Panel for Climate Change, published their first report saying effectively that climate change is real and human activities are the cause. And all of these have a sort of consequences on global temperature rise, changes in participation, sea level rise, extreme weather event, and so on, basically, highlighting the need for more observations due to the uncertainties. Only a couple of years ago, the IPCC published the most recent review. Let me find my pointer. where effectively now you can see in this plot that humans are effectively responsible for the 1 degree warming that we are currently experiencing. With black line in these figures our observations, and with different colors basically is the factors that lead into those observations. And you can see the emissions of humans contributing a lot to the 1 degree warming we are experiencing. Now, as a consequence, the Arctic Sea area, sea ice area, again, with black line is our observations, and with different colors are the different scenarios now, will practically become ice-free before 2050. And similarly, the global sea level rise by 2050 is going to rise by 50 centimeters regardless of our emission scenario. And then thereafter, the emission scenario and how we'll behave, this matters a lot. Now, in terms of the health effects, the global burden of disease published a report a few years ago, and that was found that air pollution was the fourth mortality risk factor of all causes globally. In this figure here, this is corresponding to males, but a similar plot there is for females as well. You can see that air pollution poses greater risk than, for example, high cholesterol, alcohol use, or even child and maternal malnutrition. It has been estimated to cause 7 million premature deaths annually, 213 million disability-adjusted life years, and this is just the deaths. So imagine all of this pressure that this is putting to our system with diseases like asthma, and all the consequences to the health and economic system. And importantly, it can affect every organ. So as you can see in this cartoon, as we inhale pollutants, they can translocate to our brain via the olfactory nerve. They can reach and deposit into our lungs. They can be swallowed and reach to our gastrointestinal tract. They can translocate to our blood, to our hearts, and so on. And the evidence is mounting. So air pollution has been linked with respiratory diseases, cardiovascular diseases, brain function, dementia, depression, aging, and many other symptoms and diseases, as you can see in these plots. Now, despite all of this evidence, 99% of the world's population is still living in places that exceed the World Health Organization guidelines. Now, in the plot here on the top, you see the population-weighted annual average PM.5 concentration. And now at this point, I'll draw a parenthesis. So what's the PM2.5 that I'm referring to? It's a metric that we are currently using for regulatory purposes, and it's effectively the sum of the mass of all the solid and liquid particles in the air with diameter less than 2.5 micrometers. And to put this a bit into perspective, the diameter of a human hair is about 50 to 70 microns. So now we're talking about particles that they are hundreds of or thousands, tens of hundreds of thousands times smaller. Now, typical concentrations of these particles in the air are spanning from few tens of hundreds in clean environments to million particles per cubic centimeter. And now imagine that a cubic centimeter is a typical volume of a dye, basically, as I have here. Now, depending on the source and formation mechanism, the particles detail that I will not go very much into. The particles comes in different sizes and diameter, with diameters from few nanometers to several tens of microns. Now, returning to this, this plot here distills the information from the figure above, where you can see again the average concentration of the PM2.5 in different regions of the world against the World Health Organization guideline. And now looking at the burden of this disease, so the deaths attributed to the air pollution in different parts of the world, where I'm showing in this plot here, more than half than this burden is falling on people in China and India, so highlighting the need to consider these health inequalities. But now how we can work out what's going on. And what we are doing is with aerial, ground-based, and laboratory observations, basically. And I will showcase some of the research that we are doing to understand air pollution. I will start with the aerial observation. So in UK, we have this large research aircraft, which is based at the Cranfield University, and it's jointly run by the NERC and the Met Office. And since 2004, that is being operated and has conducted measurements over 30 countries in 4 continents. An example of that research that we are doing is the flights that we are conducting out over the Southwest Africa, where the agricultural biomass burning and wildfire basically are one of the strongest contributions to the global aerosol burden. So in these plots is how the pollutants are dispersed from the southwestern part of Africa. And what we effectively did, we did flights along this path to understand the properties of the aerosols. So what we found is that over the transformation of these emissions, so if you want, after the emissions, when these emissions are transported, they are reacting with different atmospheric constituents. So over this course, within half day, the light absorption efficiency of the aerosols was increasing. So you can see, you can only just, you can check the absorption coefficients basically over a time. So within half day, we can increase the light absorption of the aerosols by 30%, leading to a warming of the atmosphere. Now, this is a satellite image over the Atlantic coast. If I'm not mistaken, this is the south coast of Spain. And all of these lines that you are seeing here, you know, when I first seen that, I thought, oh, this should be aircrafts, but I was wrong. These are all ship tracks. And this is not the case only for the Atlantic. Similar observations and similar images have been taken in many parts of the globe, highlighting that these emissions are important to the global air quality. So in order to understand them, we conducted some flights, effectively chasing ships, as you can see from these plots from our research aircraft, off the Portuguese coast and along the English Channel. So these highlighted areas on the map here. We did measurements both in emission control areas as well as in the open sea. And what we found was quite surprising. So if you see these plots here, we can see that the emissions of sulfates in the open sea are extremely larger than what's in the control areas. Again, the sulfate zone is red and organics with green. And what we found out is that these enhanced sulfur emissions in the open sea have the properties to alter clouds' behavior, basically. Now we will move to our ground-based observations as National Centre for Atmospheric Science and here at the University of Manchester. We have managed so far to conduct measurements of air pollution literally in every continent, in urban, suburban, and remote environments. And now I'm going to show you some examples of these. In Greater Manchester, last year, we conducted measurements in multiple locations. You can see here our various spots in order to understand the sources of air pollution. What we find is that the contribution of biomass burning, so our wood stoves basically, is significantly lower than what is predicted based on our national emission inventory. So the national predictions of national inventory is with yellow and our measurements are with red. Now the remaining of the emissions of this black carbon are largely attributed to traffic emission, demonstrating that still traffic is an important contributor of the pollution we are experiencing in Manchester. Now, at the same time, in order to understand the sources of pollution in the indoor environment, at the Ingenious project, we are conducting measurements in 300 homes in the Bradford community cohort with low-cost sensors, where in a subset of those homes, we are putting additional measurements for volatile organic compounds. In about 100 homes of these, we're looking at the bulk PM composition. And in 50 homes, we do detailed molecular identification. Now, this plot is from a specific house where we can see the concentration of particles in the indoor air with blue and in the outdoor with red. And what you can clearly see, so basically the bottom plot is a zoom of the top. What you can clearly see that the concentration of pollutants that we're experiencing in our homes is order of magnitude higher than what we are experiencing outside, highlighting that we have very strong emission sources in our homes. And looking this in detail, so again, the plot that I'm showing at the bottom is again the concentration of PM 2.5 inside our homes. We found that the spikes of very high exposure emissions are relating to cooking activities. So the exposure that we might be experiencing in our home is very likely to be dominated by our cooking, so something that smells nice. Now I have to mention, of course, that these are all preliminary results, so please take them with a pinch of salt. Now moving away from UK, in China, over the past year, there have been significant efforts to control the sulfur dioxide emissions. So these are the sulfur dioxide emissions over the years. Now, as a result of this, there was a disproportional increase in the relative contribution of nitrates. And what we observed effectively, it was that this increase, the relative increase of nitrates, you can see in these plots with blue, coincided with an increase in the liquid water content. So our particles were starting absorbing water due to the hydrophilicity of these nitrate species. This effectively led to haze formation and a rapid decrease of the visibility. So despite there were efforts to reduce one pollutant, then something else that came out led to increased air pollution and haze formation. All of this is just to highlight the complexity of the reactions that are occurring in the atmosphere and not simply to target a certain species. And with observations like this, basically, and with all of these measurements, we can get a picture of the chemical composition of the aerosol around the globe. And this is what these pie charts are showing. So it shows the composition of our aerosol particles in different parts of the world. Our sulfate is shown with red, nitrate with blue, ammonium with orange, and our organics, there are different shades of brown and green. Now, the take-home message of all of this is that the chemical composition of the aerosol can be vastly different from place to place. And this poses a quite interesting question in terms of whether the mass-based metrics that we are using now in our legislation were adequate measures of the pollution impacts. And if you consider from toxicological point of view, probably not. If we inhale 20 micrograms of sea salt, is this equally toxic with 20 micrograms of heavy metals? Probably not. And to highlight this complexity in the real environment, the atmospheric environment is highly complex and dynamic. So you can imagine that we have emissions from different sources, transformation processes, everything occurring simultaneously. So this makes it extremely difficult for us to understand what's going on with just our ambient measurements. And this is why we need laboratory studies. So laboratory studies provide an environment where we can isolate and study specific emission processes and fundamental processes. And an example of these facilities is the Manchester aerosol chamber that we have here in Manchester, which is effectively an 18 cubic meter Teflon bag closed in a controlled environment and equipped with lights that can simulate the solar radiation, mimicking any photochemical reactions basically that are happening in the atmosphere. This is a picture here of our chamber. So now over the years, we have developed the capability to produce emissions from real world sources like wood burning. You might have seen this trailer outside our lab where we keep our wood stove. Plant emissions, cooking emissions, and diesel engine emissions, and so on. And demonstrator of this complexity of the system, some experiments we conducted at the University of York. This is their chamber, which is of their chamber, where we studied the composition of the emissions from the ozonolysis of limonene. Now, limonene is a key ingredient in the majority of the cleaning products we all have in our homes. So if you think that anything that has a lemon smell probably contains limonene. So we added limonene in the chamber, we added ozone, which is a common atmospheric oxidant, again in levels similar to those that we're experiencing in our homes. And then we did detailed chemical compositions in the samples that we analyzed. So we detected with our mass spectrometers about 2,000 different compounds formed out of the reaction of a single component. So imagine what's going on in the real atmosphere where we have thousands of compounds reacting simultaneously. And now to add a bit to this complexity, during my PhD, we did a lot of experiments in the chamber here in Manchester, mixing 3 different precursors, orthocresol, alpha-pinene, and isoprene, which are representative anthropogenic and biogenic precursors. So surprisingly, what we found is that we find a completely different behavior in the mixture opposed to a single system. And not only we identified in the mixed system, not only we identified components of each precursor, but also compounds that they are unique to the mixture. So now the point of this is to highlight that we will never be in a position to single out the effects of every single compound in the atmosphere in every single mixture. So we need to take a different approach. And what we've started to be looking at is to understand the emission of mixture of components representing a real source. And such an example are, for example, cooking emissions, where we start frying breakfast and we fry tomatoes, eggs, sausages, and mushrooms, and all of this stuff. And in these plots, you can see the distributions of the particles emitted during different cooking times. Clearly, basically, the characteristics of the emissions can differ significantly depending on the cooking time and even what order we put things in the pan. And the same when we're investigating biomass burning emissions. So we burn wood, basically, and we found that the composition of the aerosol changed completely depending on what type of wood we are using, what burning conditions we're using, and so on. So now how do we bring all of this together? You might have seen some of our posters around the campus. And this is the air pollution hazard identification platform, or otherwise HIPDOX. So here we're bringing our expertise from from characterizing and producing different pollutants from certain sources. And with collaborators along with different universities in UK, we try to understand the health impacts from the exposure of these sources. Now what we are doing by exposing human volunteers, mice, and cell lines, we collect samples and try to identify biomarkers and epigenetic signatures to try to understand how each source affects our health across multiple endpoints. And our aim is simple. So we're trying to create a hazard ranking of the pollutant by source. For example, are diesel emissions better than cooking or wood burning? So in such a way, we will be in a position to propose effective mitigation strategies targeting specific pollutants rather than treating the particulate matter as equally harmful. A little advert here, we're still looking for additional volunteers. So if you're interested in our study, please scan this code, follow the link, or please contact me. And now in parallel with all of these, I have been awarding the Discipline Hopping Award, where we're trying to bridge basically the gap between our science and other sciences. And I'm developing methods in order to collect aerosols in relevant media, like we use simulated lung fluids and this sort of stuff to expose cell lines, in order to assess the toxicological impacts of the aerosol from different sources. And we use these methods to run a lot of other projects that we are doing, looking, for example, on the cardiovascular effects of pesticides and whether the transformation of pesticides in the atmosphere are more toxic than the parent compound. And as well as we are looking at the cardiovascular effects of the emissions from the wood stoves. And here you can see a plot from our PhD students who already found statistically significant dose response effect using rat cardiac cells. So in summary, I think that I've managed to convince you that air pollution is an important issue that affect the climate, and it's one of the leading cause of preventable mortality. So we can actually do something about it, basically. Observations of air pollution contribute to understanding of processes occurring in the atmosphere and can aid the development of mitigation policies. And the indoor air quality is worse than outdoor, and cooking emissions are a strong contributor of that. As I've shown you throughout my talk, that the composition of the aerosol is extremely diverse, posing an impact on the mass-based metrics we are currently using in our policy. And we will never probably be in a position to understand the effects of a single component. Therefore, probably it's more relevant to start understanding the ranking of different sources in order to provide more insightful policies. However, this necessitates for multidisciplinary approach, and this is what we are trying to do here. And we're always looking for new collaborations across disciplines. Thank you so much. I might have run a bit over time. I apologize. And these are the acknowledgements to all the people being involved, because there is so much work in this. Thank you.
And thank you. Another really interesting talk. I've noticed that little trailer outside of the back of the Simon building. I was wondering who inside it.
It's a little wood stove. Yes.
Yeah. We've got a few questions here. How can the UK government incentivize decrease in home-based air pollution?
Sorry, can you repeat again, please?
Oh yeah. How can the UK government incentivize decrease in home-based air pollution?
So ventilation is important. Ventilation is one of the key things that, as you can see, the outdoor air pollution is always lower than it is in our homes, right? So by opening our windows or ventilating the air, we're effectively diluting whatever we have in our homes based on what it is outside. So this is one of the key things, I think. Whether this is extractor fans, while we are cooking, as you've seen, I've shown emissions from cooking are quite significant. So the extractor fans are doing quite a good job in this, I think, as well as ventilating. While we are cleaning, again, we can have open our windows. This is quite important. And as an example, actually, we did some experiments while I was a student, and what we will be doing is that we produced some aerosols inside the lab, measuring the pollutants, and then we're opening the windows to see how this will respond, basically. And just opening the windows, all the concentrations of the pollutants went quite low. I can't stop.
Yeah, so connected to that is another question, say asking, is it common to cook over gas stoves without ventilation in the UK?
Sorry?
Another connected question is it common to cook over gas stoves without ventilation in the UK?
I have no idea what this one is in the homes, but yes, I think actually many places that I lived as a student, there was no ventilation at all. So I assume that that's it's quite common, especially for students.
And another question here. If you manage to develop a reliable, robust particle or pollution measuring device, would you be looking to commercialize it?
Oh, so yes, maybe I should have said that. So as I've showed in my talk throughout, as you see, the air pollution is so diverse. There is so diverse chemical composition of the aerosols or the gas and particle components. So it's now, in order to be able to measure the good breadth of it, we need multiple instruments, not only one. One instrument will never be able to tell us what's in such complex mixture. So if I was managed actually to do it, then of course I would, but we need multiple instruments worth quite a lot of money to understand what we can understand. And there is still fraction that we are not able to detect still.
Brilliant, thank you. The questioner responded saying, in the US, stove use is mixed between electric and natural gas, the latter being much more toxic. Yeah, so it's a similar situation in the UK, I think.
Yeah.
And probably the final question, how do you think air pollution will respond to the upcoming net zero carbon targets?
Oh, that's an interesting question. So what we've seen and what I believe that it will happen is that we will electrify our fleet. This is going to happen sooner or later, despite you've seen the traffic emissions are quite important still in Manchester. Sooner or later, we will electrify our fleet. So the emissions from traffic will definitely reduce. What's quite interesting, what's becoming more and more important is the emissions of what the so-called volatile chemical products. So products like pesticides, like flame retardants, like siloxanes, all of these are products that consumer products basically. And nowadays the contribution of these emissions start to becoming more and more important. And we don't know anything about it yet. So, and this is where I think the field is starting to go. We're starting to understand how these stuff are working. This is why we have all of these projects with pesticides and so on. That's my guess on this.
Okay, brilliant. Thank you. Thank you to both of our speakers today. Really interesting talks, both of them, as I said. We've got another one of these next month. I think there is a mailing list to join to be kept abreast of those. But yeah, thanks again for both of our speakers joining us. The next one is on the 22nd of June. There's a register link in the chat there, the Eventbrite link. Yeah, so thank you very much. I'll see you next month.
Thank you.
Goodbye.
Bye.